week? It was. My clock says we should start. I should turn down the volume. Okay. Let's see. So you're in the middle of MP2. The extra credit deadline is tonight. After that, we'll be running the grading. We'll be doing our test cases every night, starting Saturday night on the actual, end of the MP, on the complete MP. So if you get a 100 by the grading run on Monday, you are done. We're not going to add test cases at the deadline, okay? These are our test cases. So grading of exam one is done, yay! Grading of exam one will happen momentarily. When it's finished, your scores will be pushed into your Subversion repository into a folder called exams. Similarly, all the quiz grades that you are accumulating will be in a folder in your Subversion repository called quizzes, or maybe just quiz, I don't know. But they will be there. Very soon we will deploy the course gradebook, which will allow you to see sort of the full summary of how you're doing in the course. But we just don't have that going yet. Let's see. Any other administrative questions or issues you want to talk about before we actually work today? Yeah? What did you say? So, is it going to be the graded, or will it be eventually automated? So the question is about grading of quizzes. So quiz grading, we hope, as you probably do too, we hope that I'm talking lab quiz grading, will all be automated. I don't think that that's likely to be automated in real time, though. So it'll be automated, but just not while you're sitting in the lab, is my guess at how this is going to unroll. Certainly that should be your expectation. Let's see. Oh, the handwritten version of your exam, the piece of paper, will be used as sort of fault tolerance. It'll be used as a fallback just in case something goes wrong with Prairie Learn. Oh, but don't worry about it. Nothing ever goes wrong with Prairie Learn. Oh yeah, we were done with our quiz last night. So. All right, let's see. So, and exams will be run through an autograder. So your exams, the things you take in the testing center, will be autograded. Again, not likely in real time this semester. Eventually that will be a feature, but we don't know a timeline for that, okay? So it'll always be a bit of a process, but hopefully the turnaround time will never be too bad. Okay, so for the last week, we've been talking about the behavior of C++ in the context specifically of passing parameters and getting values back. That is, we've been talking about, among other things, we've been talking about the way the scoping mechanism works. The way the scoping mechanism works with respect to your variables. So for example, we wrote code that when you pass a value parameter to a function, gets deployed for you by the system. When I describe it like that, what construct am I talking about? So let me say it again. You didn't know I was going to ask a question, right? Okay, so there is code that is deployed for you when you pass a value parameter to a function. What code is that? What's it called? copy constructor. Okay, that's the main original point of the copy constructor. Okay, was to make value parameters possible. Okay, similarly, the scoping mechanism, when it removes local variables from the stack and passes control back to the calling function, it has helper code that it deploys. That helper code is called the, starts with a D, destructor, right. Name something that you've done that starts with a D in this class. Destructor, yeah. Delete, oh, okay. The destructor deletes. Okay, all right, so we were talking about the copy constructor, and there's a lot of details about when it's deployed and how it's used and what it does. And we talked about the destructor, what it does, how it works, when you need it, those things. And now we brought up one last issue. And that issue should have felt kind of the same to you, but in this case, there's no function that you're calling. The context in which these issues arise are slightly different. So let me review that for you for just a minute. We were talking about what happens when you make an assignment, simply when you make an assignment between variables, okay? So now let's take this scenario. Let's pretend we have an object B, and it looks like this. Can you see what this is? The sphere, wet, rocky, rotating, inhabited. It's the Earth, okay? And we have an apple, a good old apple here. And now the question is, what happens by default in C++ when we make a simple assignment like that? And the answer is a member-wise assignment. And what that means is that the members, the data members of the object, are copied for you, okay? That means this double becomes 2.5. This 4 becomes 3, because doubles and integers know how to copy themselves. And when this member is copied, what happens? This pointer gets the value of this pointer. What does that mean? Yeah? Yeah, how about this? Is this what happens? Yeah? Yeah? Uh-oh. Two problems. First one. Somebody tell me the first problem with this. Yeah. This is a big old memory leak. Okay? And the second one is that we almost certainly do not intend to mix up B and A like this. We almost certainly intend, when you make an assignment statement, B equals A, you intend for B to look like A, but to be a completely different object, okay? And now all of a sudden, we have tangled those up. Now, I am not asserting that sometimes you won't want to design objects that share some memory, but if you do that, you're going to want to have a different mechanism for sharing that memory than exploiting the default behavior of the assignment operator. It's almost never, I'm never going to say never, never, because somebody will say, yeah, but what about? But it's almost never the right thing to do to not reassign, to not reallocate dynamic memory upon assignment. Okay? All right, so this first example illustrates two things that our re-implemented assignment operator needs to do. Let me spell out for a second what I mean by re-implemented assignment operator. This B gets the value of A. This assignment statement is semantically equivalent to calling a member function on object B whose name is operator equals and whose one argument is A. Those two things, exactly the same. And in fact, that's the code that we're going to write to deploy when an assignment is made. The system will go, oh, you wrote equals, but I know what you meant. You wanted me to run this other function, okay? All right, so what are some things that our function is going to have to do? It's going to have to clear out the old yucky memory associated with the object, and it's going to have to make a new copy. Okay, and I'm going to write those down as sort of these 1 and 2 because this is part of our planning process for writing the code on the next page. Okay, any question about that? So that's one of the things that we're going to have to do when we write the assignment operator. Clear out the old, copy over the new. Okay, I want to give you an example of something else that we need to worry about as we write an assignment operator. Suppose that A and B are already just two different names for the same space, okay? A and B are already, when you say A equals something or A dot something equals something, they already, A and B, already refer to the same memory chunk, okay? We can look at examples of how that might be the case. Lots of different ways, actually. But think about if that's the case, if A and B are just different names for this same memory, and we deploy this strategy for making the assignment, what happens? First, we clear out the memory associated with B, and then we don't. We just stepped on ourselves, right? I don't even know how to do that, right? We just cleared out the memory that we're going to need to make a copy of. So the way I'm going to describe the thing that we need to prevent is I'm going to say we need to protect against self-assignment. So the third thing we need to do for sure is protect against self-assignment. Okay, any questions about that? Okay, third thing we need to think about when we're writing our assignment operator. Can you do that in C++? Yeah, this chained assignment, perfectly legit in C-based languages. What it means is take the value of A and assign it to B and assign it to C. Okay, so in the end, you have 3 different things, all of which look like A. Okay, all of which look like A. Okay, well, let's tear this apart for just a minute. I already told you over here that the assignment operator really looks like this. Okay, so looks like this function call. So B equals A looks like this. I'll write it here. B dot operator equals with A as an argument. Okay? Now, this other assignment looks like that too, right? It's C dot operator equals, and then an argument. What goes in that argument? What is that argument? What's the value of that argument? Yeah, look, that's that whole right-hand side, right? It's this thing. It's this whole thing right here. Goes right there. So what does that mean about B dot operator equals A? What does it mean about that function call? It has to return a value, right? It has to return a value. And for right now, I'm going to just write that as return a helpful value. And we'll talk about exactly what that looks like while we're writing the code. Return a helpful value. Any question about all of that? It turns out that these are the 4 considerations that we need to have as we write the code for the assignment operator. Let's see. Oh, writing an assignment operator at this point, you should feel like you should roll your eyes and consider it to be a piece of busy work. Because every assignment operator you're ever going to write forever is going to look a lot like the one on the following page. In fact, I, at this point, do a cut and paste kind of thing. Oh, I don't want to write that again. Find the last one you wrote, copy it in, and do some type changing. And that's pretty much it. So let's go see if we feel like that's true. We'll get to a place where we believe that that's true. Okay, so let's write this, okay? I want to do it in the order that we mentioned it on the previous page. Clear the right-hand side, or clear the left-hand side, copy the right-hand side, protect against self-assignment, and return a helpful value. We'll do it in that order. Okay, so here are my 2 objects, the same ones that we used in the example on the previous page. Tell me exactly what the code is, given our, given our fancy sphere that we had. Exactly what is the command that we need to invoke? What is the statement that will clear the left-hand side? Somebody raise their hand and tell me what I should do. Yeah, Mark? Delete, good. Delete the array. Yep. Oh. That's just a typo. Okay. Any question about that? And that's it. Because now this space is given back. The rest of B we can just reuse. And we're good. Okay? Now, the issue of copying A, of making a copy of A into the space for B, unfortunately we can't use part of what the system gives us for free and deal with the memory portion ourselves. Rather, we have to explicitly do the whole copy. For that purpose, the list of members in the class is like a checklist of assignments that you need to make. So you go through and you make sure you have a data value for each of the members in the class name. So what's the first one? It's a little bit obfuscated, but I'm pretty sure that to make a copy of the right-hand side into the space for B, all I have to do is set the radius equal to right-hand side's radius. And I have to set number of attributes to right-hand side's num attributes. And now things get interesting. I need to make my own space, ats equal new string. How many of them do I need? That many of them. I'm almost done here. And then I'm just going to copy each one of them over. I equals 0, int I equals 0, I less than. Oops. Okay. Yawn. Any questions about this? Any questions? I think I would have a question if I were you. Where have you seen this code before? Yeah? So the question is, did we really do the copy of that array? Okay. And the answer is yeah, because we deleted it first. So there weren't 4 there ever. We got rid of everything associated with B, right, via the delete statement. And then we said it's a clean slate. How much memory do we want? We want 3 spots now. We want right-hand side's number of attributes. Okay? We've already made that copy of the number of attributes. Okay? Anything else bug you about this code? I think you should kind of even be bugged about it. And the way to prompt what I'm getting at is you've written this code before. Where? Yeah, look, all this mess right here, this is the code of the copy constructor, right? And how about this mess right here? That is the code of the destructor, right? And guess what? That will always be the case. So what you're sitting there thinking is, well, why don't we just call the destructor? Why don't we just call the copy constructor then? And the answer is, well, we could, except that the destructor and the copy constructor, by principle, are functions that you write for the system to use. If you use it and the system changes, then you're still subject to the way the system chooses to deploy those things. Now, I'm only kind of, speculating. It probably would work just fine for all the C++ compilers going forward forever and ever, but you save yourself from that risk if you don't assume that you can use something that's designed for the system, and in fact, that you make your own helper functions that do these 2 tasks, and then the destructor uses that helper function, the copy constructor uses a helper function, and the assignment operator uses both of those helper functions. So by convention, that is, you don't have to do this, but it's recognized practice that it's a good idea. Rather than actually writing delete ats or whatever there, we write a function called clear, and we pass to it, oh no, we don't have to pass anything, and a function called copy, and we pass to it right-hand side, so we know what we're making a copy of. Okay? And then the destructor calls clear, and this one calls clear, and the copy constructor calls copy, and this one calls copy. Okay? Any question about that? That is all by convention. That's what people who read your code are going to expect it to do. Yeah? On the inside, sure. Yep, sure. It'll be the same. It'll look the same. All right, I have questions for you, of course. So clear and copy are helper functions, right? They are separate functions that you are defining that you intend to use. Where are they defined? Where do they live? Where do clear and copy live? Where do they live? In the class, right? They are class member functions, right? They are sphere class member functions. Okay, fine. Are they public or are they private? They are private, that's right, because the last thing you want is client code going, I think I'll clear that out, right? You don't want to give the clients the ability to stomp on your data because they'll use it, right? Or to make copies of it, for that matter, right? So clear and copy are private member functions of the sphere class. Utility functions that you write, it's great practice to do so. You just tuck them behind private, never expose them to the client, write as many as you want. I think most of our MPs allow you to do that going forward. Let's see. Oh, the other thing I wanted to say about this is you are actually asked to write one of these things for MP2. The one we ask you to write in MP2 is a little teeny tiny bit more complex than this, okay? Just is. So, and we know that. We want you to struggle over it. So just going to tell you that. But the fundamental underpinnings and the questions that you want to ask yourself about what should this code do are kind of the same as this. How do I clear out my memory? How do I make a copy? Sketching is good. Drawing pictures, giving yourself a model for what's going on in memory is good. MP2 does something more like this. Instead of strings, you've got string pointers, say. They aren't string pointers, but imagine how you would clear out the memory if instead of strings, you had string pointers. Okay? All right, any questions about all of this? Okay, I have one more question for you about it. Oh, yeah, we're only on number 3. What am I talking about? Okay, so we need to protect against self-assignment. That is, we're only going to do these 2 things if A and B don't already name the same memory. Okay? So I'm going to write pieces of that, and you help me fill it out. So we're only going to do this if something is true. And in order to fill this out at all, I need to remind you of the fact that keyword this is a pointer to, or the address of, same thing, the current object. So in the case of B dot operator equals on A, this is the memory address of B. Okay, this keyword is the memory address of B. All right, so what I'm pretty sure we want to check out is a relationship between this and the right-hand side. How do I untangle what that looks like? First of all, take a look at it. Are types okay? Can I do that comparison right now? No, that's right. And so I have to make one of them into a pointer, or I have to dereference one of them. What do I want to do? Oh, right. Oh, well, I'm pretty sure that what I want to do is make sure that this and the address of the right-hand side are not the same. Right? Because in this picture, take a look at this picture for a second. This picture. It's the memory. The fact that they name the same thing is really just saying the location of those variables is the same, or their memory address is the same. So in order to protect against that, we make sure that those 2 memory addresses are different. Okay? You buy it? Okay, right? Whatever. Okay, fine. Close all these brackets. And now finally we want to return a helpful value. We want this kind of thing. The return value is a sphere. We happen to be returning it by reference. But the value that we need to, or the type of the thing that we need to return is a sphere. The sphere that we return is this one. This one. Okay, we could return the value of the right-hand side too, but we just happen to return. Oh, no, we can't. Oh, yeah, we can actually. We could return the value of the right-hand side too, but we turn the value of this. Should I be worried about that reference? Returning by reference. Should I be worried about returning by reference here? It's always a great question to ask. When you're returning by reference, you should just go, is that okay? Is that okay? It turns out it is okay in this context because this lives outside the function. This is not a local variable. You should not return a local variable by reference because by the time you need it, by the time you refer to it, it's gone off the stack. But this has existence out here. This out here is just B. Okay? The dereference of this is just B. So you don't have to worry about passing it by reference or returning it by reference. Okay, any questions about any of this? As I said before, there you go. That is every every assignment operator you will ever write looks a lot like that. Okay? Type you'll just change the types. Okay, but I have a question for you. So there it is, written more neatly. Yeah? No. No, this is always the name of the current object, no matter where you use it. Yep, so it isn't it's the dereference of it, the value of it. Yep, because this will be there, it's B. Yeah. Okay, I have a question on the board. I hope you're thinking about it and what it means. The question is, look, if I have A and it's the Earth, and I have B and it's the Earth, why are we going to make the assignment? They're already the same, right? Don't we want to, I'm going to give myself a little picture to refer to here. Here's B, here's A. You know, I don't know, I'm going to make them look that they're already the same. Same, it's supposed to be the same. Kind of look the same. They're already the same. So why don't we use that for our criteria of deciding whether an assignment should be made? We're only going to make an assignment if they're not already the same value. Why don't we do that? Not going to answer it. You guys have to. Yeah? Uh-huh. Yeah, but you can argue that if A looks like this and B looks the same, and you do an assignment, you kind of wasted your time, right? Because they were already the same, right? So wouldn't it be nice if we could just avoid it? Why don't we do that? What's wrong with that? Yeah? We're in the process of defining what is equal to be, oh. So equal is the assignment, and you're right that we don't know what it means for two of the things to be the same. That is, we don't have the assignment, or we don't have the logical operator that checks to see whether they're the same. You're exactly right. We don't know how to do it, right? Like if you say, is sphere equal to sphere A equal to sphere B? Sphere A equal sphere B? Does that work? What happens? I don't even know what happens by default. I'm guessing the system will go no by default. And that would be the safe thing, I think. So what does that imply? In order to compare two spheres, what would we have to do? Yeah, look, if we decide this is what we want to do, we have to overload more operators. We have to overload the comparison operators so we could tell whether or not spheres were the same, which is what she said. Okay, so let me write that down. Need to overload, not equal to, and probably all assignment operators at that, all comparison operators at that point. If you're in the business of comparing spheres, you better be able to do it any way you like. Okay? I don't know if it means you give it a notion of less than. I don't know. Okay, so that's a problem, right? That's incurring cost, development cost where we can make a mistake. So we kind of don't want to do that. Even if we decided to do that, is it a good idea? Tell me about the process of checking to see if two things are the same. What would we have to do to check to see if these two things were the same? Yeah? Yeah. Yeah, look what you'd have to do. You'd have to go through this, you'd have to check these, of course. You'd also have to go through this dynamic array, checking each one of those for equality, right? To make sure they really, really, really are the same. How long does that take? about the same amount of time it takes to make a fresh copy, right? Just checking, even if they do turn out to be the same thing, you might as well be just making a fresh copy. Who cares? You're looking at all that data anyway. Okay, so let's see. Checking for equality is as expensive as copying. So the last thing is kind of subtle. The last bullet point here is kind of subtle. If a client says B equals A, if the client says that, and we short-circuit it and say, no, you don't really want to do that, do you? It's kind of assuming a lot of power on the part of the code that you write. So if the client code, for whatever reason, wants to make this assignment, we should implement it if we can. So we don't want to take that power and that responsibility away from the client code. They said they want to make an assignment. They said they want separate copies of these things. So we're going to write the code to make that happen. It just so happens we can't if they name the same space already. Okay, so assume that, let's see, why not this value thing? Let the client make the assignment if they want. I had a metaphor for that last hour. I can't remember what it is now. Don't know. The principle, I guess. Okay, any questions about all this? So really, really, really now you know everything I know about writing assignment operators in C++. Okay? Oh, except the following. We have this rule, and it simply says that all three of these functions that kind of feel the same, these three functions that the system kind of deploys for us, if one of them should be written, then all of them should be written. So if you have reason to implement any one of the destructor, the copy constructor, or the assignment operator, then you must implement all three. Where must is you would be an irresponsible programmer if you don't. There's nothing in the system that reminds you of that. Okay? So you must implement all three. Now, what is that reason? If you have a reason, what is that reason? What's the reason? What is it? You want to make separate copies, that's right, aka deep copies. You want to go deep in the object. What tells you that that would be necessary? What about your object demands it? Yeah? Yeah, if your object has dynamic memory, that's right. The reason too is your object employs dynamic memory. Have you used the string class assignment operator? Have you used the string class assignment operator? Does the string class have a custom assignment operator associated with it? Have you used it anywhere? Does it have a custom one, or did the standard one go? The answer to that is we don't know. We don't have to know. It's encapsulated away from us. The fact that the string class can be used to make us, this is an example, not a specific piece of knowledge. The fact that you can use the string class across an assignment statement and it works, that means somehow The string class is assuring you that assignment is okay. Whether or not there's a custom one, it's kind of none of our business. Now, do you think there is a custom assignment operator in the string class? I think there probably is, because I think a string is a dynamic array of characters, probably, right? So there probably is a custom version of an assignment operator for strings. Who knew, right? That behavior, that behavior of an object where you don't really have to guess whether or not assignment will work correctly, that's your goal in all of this. You want to make your objects so that in such a way that client code can use them the same way they use all the other objects. Now, I will tell you that the first image class that we used in this course is called EasyBMP, and I found it one night online. Very simple interface to manipulating images. Oh my gosh. Whoever made this class, completely irresponsible with respect to their use of memory. The first thing we did was we implemented all of this particular memory management code so that this would be a more robust class. So that if you said BMP1, BMP2, and made an assignment across it, it would work fine. You kind of think that should work, right? Okay. All right. I want to kind of switch gears here for just a second. If this were a textbook, if the semesters, our shared time here, were a textbook, this would be a, moving on to a new chapter of the textbook, away from the nitty-gritty of responsible memory management and into characteristics of object-oriented programming languages. In particular, we're going to look specifically at this characterization. The characterizations that says any object-oriented programming language will implement encapsulation. Okay, we already talked about that a little bit, and I'll come back to it in a sec. Inheritance, another keyword, it's what we're going to focus on next. And polymorphism, which we'll talk about a little bit more later. Though operator overloading, it's a religious discussion about whether operator overloading is really polymorphism, but we'll have that discussion when you're a little bit more mature. Okay, so these are, bye, we'll miss you. Friday. So this is one way of characterizing object-oriented programming languages. And by the end of the course, you should have answers to the questions of how does C++ implement or allow the language to implement each of these three characteristics? How does it work in this context? How do these things work in the context of C++? The answer to what's the relationship between encapsulation and C++ is the following. In C++, we separate the interface from the implementation in two ways. One is that we hide the data behind private access from the client. So we hide our data associated with the objects using the keyword private. The other is that we compile, we can and we do, compile the class definition via the header file separately from the full implementation. Okay, so those are two things about C++ that reinforce the idea of separating interface from implementation from a client's perspective. Okay? Next time, we're going to spend all day long talking about this notion of inheritance, and in particular what it means for code and reusing code and software design. Now, that's actually a lie, because we don't spend near as much time as we should on design, and we spend most of our time on how does inheritance even work in C++. But it's Friday.
Uh, so for those of you who came for the EC110 workshop, there's some hand up. Hi, Victor. So those are the handouts for EC110 workshop. So if you just came in, there's some handouts here. Here. No, that is one. That's not that one. This one.